Good day. Welcome to our general mathematics class. In this video lecture, you will be learning another mathematical manipulations, another skill that you need to learn in order for you to know and master how to operate on functions. You already learned about evaluations and functions and operations and functions. This time, this is another, or let's say, auxiliary lesson for operations and functions and evaluations and functions. This is composition on functions. From the name itself, composition, composed. A function can be composed of another function. You know it already that a function is denoted with f of x, or f is the name of the function and the x is the input, which is inside the parentheses. And in the composition on functions, a function can be composed of another function, and that another function is inside that parenthesis. So that x will be replaced with another function. So that is compositions and functions. Let us define now some terms and symbols of the composition on functions. So let f and g be functions. For example, you have two functions. Then the composite function will be denoted by f is composed of g is defined by f is composed of g is also equal to f of g of x. As you can see, instead of using a number, we used another function, and we know that this function has its expression also. So this function f has an expression, okay, or the output range. And whenever it has the value of x or any variable, it should be inputted with another function. In this example, we only have f and g. There are two functions. That means the second one, which is the g, will be the input, while the f is the output range. Okay. So the process of obtaining composite function is called function composition. Composed. I hope you get the idea already. This is, let's say, a little bit tricky, but still very easy to learn. Just try to remember the evaluation on functions. Let us start right away with our first example. Let's say you are given with these two functions, f of x and g of x. You can see its expression. And then you are asked to find f is composed of g of x. And the other problem, this is vice versa. You are asked to find g is composed of f of x. This time, we only have the value of x. We do not have any number or any input for x. For now, our input will be the second one, the latter, or the g. Okay? F is composed of g. Try to remember again the idea. F, a function f, is composed of g. G is the input this time. So it is denoted with this symbol. F of g of x. Okay? Again, from f is composed of g to x, it becomes f of g of x. As you can see, instead of using f of x here, we use f of gx because of this problem. That means in every x that you can see in the function f of x, which in this example we only have one, we are going to substitute the function of g of x, which is x squared plus 4, in this x here, in f of x. So again, the first function should be the main output range, and then the latter one, or the second one, g, which is on the right side, is the input now. Okay? That is very easy. Let us start. We all know that f of x is equal to 4x minus 5, therefore, we substitute the value of g of x in this output range, or in this expression. So it becomes like this now. From x it becomes x squared plus 4. 4 times the quantity of x squared plus 4 minus 5. And then you can continue the process now. You're just going to do the distributive property. 4 times x squared, that is 4x squared. 4 times 4, that is 16. And then bring down or copy negative 5. Simplify like terms. 16 plus negative 5, that is positive 11. This is now your final answer. What if you are going to do it inverse, or let's say vice versa? G now is our output range and F is our function, or let's say input. So the same process, we are just going to use the G of x now as our output range, which is x squared plus 4, and then substitute f of x, which is 4x minus 5, in this term, which is we only have 1x. Okay, so G of f of x now, so it becomes G of f of x. Therefore, the f of x is to be substituted here in this x value here. It becomes f of x squared plus 4. And substitute now 4x minus 5. Where did we get this one? From here. From here. So 4x minus 5 squared plus 4. Bring down 4. Okay. And the next step is to, okay, find the factors. Now find the factors of this perfect square binomial, or let's say trinomial. 4x minus 5 squared. Okay, that is the final answer. Now you will have 16x squared minus 40x plus 25 plus 4. But yes, we're going to combine like terms first and simplify. Okay, so 4x minus 5 squared becomes 16x squared minus 40x plus 25. You transformed it, okay, from this perfect square to this trinomial, 16x squared minus 40x plus 25. Okay, bring down 4 and then simplify. This is now your final answer, 16x squared minus 40x plus 29. Okay. There will be separate video, just a review on how you can transform this 4x minus 5 squared into 16x squared minus 40x. That is a review. You already learned this one in your junior high school. Okay. Let us proceed to another example. Let us make this quick. So this time, you are given 5 functions. F of x is equal to 2x plus 1 and so on. You're only asked to find Q is composed of f of x. Again, we do not have the value of x this time, so we're just going to use the f as our input and q as our output range. So you have, okay, find the function q. Function q is here, x squared minus 2x plus 2. Okay, x squared minus 2x plus 2. So you are going to use that one here. Okay, as you can see, we just directly substituted the value of f. Okay, take note, this is the small letter f, which is 2x plus 1. So 2x plus 1 class, we're going to have this, again, square root. So 2x plus 1 is from here, and then it is substituted to this x here. Okay, so from x, it becomes 2x plus 1 here, squared, minus 2, and then we can find another x. So substitute it again, 2x plus 1, negative 2 times 2x plus 1, and then bring down to copy 2. And then simplify. So you have 2x plus 1 squared, and then it can be transformed into trinomial now. So again, there is another video for this. Okay, so below this video. So 4x squared plus 4x plus 1. Okay, it becomes like this now. From 2x plus 1 squared, it becomes 4x squared plus 4x plus 1. How were we able to do this? On the next video. Okay, so this one, you have it here, negative 2 and multiplied by 2x plus 1. Very simple, distributive property. Negative 2 times 2x, that is negative 4x. Negative 2 times 1, that is negative 2, bring down 2. Then combine like terms, you will have 4x squared, no other term, which is the same with this term, so with the same degree, so just copy 4x squared. Plus, okay, 4x minus 4x, that is 0. Okay, 0. And then you also have negative 2 plus 2, that is 0. You're only left with positive 1. So this is now your final answer. How about this example? We are already given, okay, with the value of the input, another input, we now have two inputs, okay, which is 2 here. As you can see in this example, we are only using x. This time, we are going to use 2 as our another input. And we know also that f is our input. So first thing we need to do here is to solve first for evaluation and function for the second function, which is f, or our another input. Combine the two inputs. Okay, so f is here, f of x is equal to 2x plus 1. The same process that we did in evaluation and function, just substitute 2 in every x that you can see in the function, 2x plus 1. So that is f of 2 is equal to 2x plus 1, substitute 2 here, so it becomes 2 times 2, that is 4 plus 1, that is 5. And then since you have now the value of f of 2, you can now proceed substituting the value of f of 2 to q. Okay. So this time q is x squared minus 2x plus 2. So all you need to do is to substitute the value of f of x, not this one anymore, not this entire function, because you were able to solve this value already. So you have value of x now is 5, so that becomes, from x squared it becomes 5 squared. From negative 2x, that is negative 2 times 5, and then copy 2. Simplify. 5 squared, that is 25. Negative 2 times 5, negative 10 plus 2. Do the PEMDAS thing, and then you have 17 as the final answer. Another example. Okay, this is another example. This is rational function. Okay, so this is f is composed of r of x. Okay, again, f is composed of r of x. So you again find first the first term or function, which is f, 2x plus 1, and then r is a rational function now. So it is another let's say challenging thing for you to manipulate these algebraic expressions. Okay, 2x plus 1 over x minus 1 is our input now. Okay, so there is no need to worry about this, because this is just another this is just an x, no value for this. Okay, so you have f of r, so it becomes like this now. So start with f. Again, f is 2x plus 1. Substitute this entire function here, 2x plus 1 over x minus 1. You have, from 2 times x, it becomes 2 times the entire function of r of x. So 2 times the quantity of 2x plus 1 over x minus 1 plus 1. Okay, next step is to distribute. Okay, or let's say to multiply. So you can multiply 2 times, okay, or this is obvious that it has denominator of 1. So 2 over 1 times 2x plus 1 over x minus 1. So no need of finding the LCD, just multiply directly the numerator to numerator, denominator to denominator. Okay, since it has 1 Raman here. Okay, well, you can do the other process, but this is just simple way of doing the process. So 2 times 2x, that is 4x, 2 times 1, that is 2, and then copy the LCD, which is x minus 1. That's it, plus 1. And then we are not yet done, since we are adding another fractions, from this fraction to this fraction, this is fraction, it has over 1 here. Okay, over 1. Okay, so in this over 1, you can, okay, you can find the LCD. In this example, the LCD is x minus 1. Okay, so again, do not add it directly. You cannot add 2 plus 1 directly. Okay, so you need to find the LCD first. Treat this as a function. As a fraction. So you have x minus 1 is now our LCD. So you can divide x minus 1 divided by x minus 1, that is 1, times 4x plus 2, that is still the same, 4x plus 2. Next, LCD again, x minus 1 divided by 1 as our denominator, obvious it has denominator, okay, times 1, that is x minus 1 still, okay. Okay, so you have 4x plus x combined like terms, that is 5x. 2 plus negative 1, that is positive 1 over x minus 1. That is now the final answer. Okay, this is also another example. Okay, another example just the same with example number 2. Yeah, so you have, this is the bigger one. Bigger f is composed of r of 5. This time we have the input or value of x. So again, solve first for the latter or the second function, which is r of 5. Treat this as r of 5, like this, r of 5. So r is here, 2x plus 1 over x minus 1. So that becomes 2x, becomes 2 times 5, that is 10. Plus 1, that becomes 11. 5 minus 1, that is 4. Therefore, this, and then you cannot simplify this. Therefore, this is now the value of r of 5. And then you are going to substitute the r of 5 to the function of f, the bigger f. Okay? The bigger f is x plus 1. Very simple. So 11 over 4 plus 1. Okay. So again, do not add it directly. You are going to find, but this time, you can divide it using, let's say, calculator. Okay, using calculator. Or you can do the other way, like finding the LCD. Okay, so 11 divided by 4, that is 275. Bring down 1 plus 1, so that becomes, let's say 2 plus 1 is equal to 3. Okay, that is if you are going to use calculator, 2.75 plus 1, that is 3.75. That could be the answer. But in this example, maybe there is an error here. Like you are going to have the answer na lang, 3.75. That would be the answer. Or you can do the LCD. LCD for this is 4. So 4 divided by 4, that is 1 times 11. That is 11 over 4. Still the same. So this will be the final answer. 3.75. That is the final answer. Okay, so that's it for this discussion of the composition of functions. Kindly see the next video for this, for how we are going to transpose, or let's say how to convert the perfect square to a trinomial. Thank you so much.